Okay, hello, hello, hello. Hello, hello, hello. Hello, hello, hello. Hi. Hello, hello, hello. It's 2 a.m. Oh, wow, I appreciate that. Okay, Stefan. Okay, Chandu. Hello. Thank you, thank you. Hello. 3 a.m. Wow, wow, seriously. Right now it's 5 p.m. in LA. So it's the afternoon for me for the very first time. 1 a.m. Okay, cool. Okay, so I'm just going to get started. What I'm going to do is I will try to do a live stream like every week to do some AP calculus questions, especially, the AP exam is approaching, right, in May. So we have about like 2 months, less than 2 months or so to prepare for the AP exams. So if you know any of your friends or your siblings who are taking AP calculus, I will try to make this like a weekly thing. Okay, so I think that will be what what I will be doing. And then Gustavo, hello, Japan. Okay, hello, hello. And if you guys want to download this file, the link to the file is in the description, so you guys can download it. And the best part of this is that these are the actual AP exam questions, and I'm just kind of categorizing all of them onto a file. And today we will be doing limits, and maybe next we can do some derivative, and then some integrals, and then some related rates, some min-max questions after that. And I know some of you guys have taken like AP calculus in the past already, but I want to do this for the people who will find this helpful. C. Okay. And once again, if you want to try these questions on your own first, once, once again, if you want to try these questions on your own, you can download the file. The link to the file is in the description. Good stuff. Okay, bye. I'm so sad to see you go, but okay. But anyway, AP stands for Advanced Placement, and we are doing calculus right here. And it has two levels. The first level is the AB version, and then the other level is the BC. And I'm going to give you guys like just 5 questions today. I'm going to train for my marathon later on, so I will just do the 5 questions for today with you guys. Okay, enough being said. First question right here. This is from 1969, which is about 50 years ago, right? Anyway, it says if f of x is defined as follow right here. This right here is when x is not equal to 2. But when x is equal to 2, we have f of 2 is being equal to k. And we know f is continuous at x is equal to 2. So in this case, what shall we do to actually find out the value of k? So I will just take about like 15 seconds or 20 seconds or so. You guys can comment down below, let me know what shall we do right here to actually figure out the k value. L'Hopital's rule. Okay, yes, because you are going to do what? Limits. Yes, of course, we're doing limits for this. But a lot of these kind of questions, they are just asking you limits by in a different way, right? So in order for this to be continuous, we have to make sure the limit when x is approaching to 2 for this expression has to be the same as k, and that's pretty much just find out the k. That's how we find out the k value. So k, it has to be the limit as x approaching to this expression, and we have x minus 2, and on the top square root of 2x plus 5 minus square root of x plus 7. And now, suppose if you are a tutor or teacher, or maybe you are just a calculus 1 student, AB level is the level that you're not supposed to use L'Hopital's rule. So in that case, what should we do? Aha, yes, because we actually get 0 over 0 if you plug in 2 into the x, right? So we will just have to multiply by the conjugate So this is actually pretty straightforward. This is like the typical limit questions. And we will just go ahead and do that. Let's multiply the top by this. Square root of 2x plus 5, and then plus square root of x plus 7 over the same thing, of course. Square root of 2x plus 5, and then plus square root of x plus 7. Well, it depends. Like the AB depends if the teacher taught you or not. But like back in the days, L'Hopital's rule was not on the AB curriculum. It was on the BC. But yeah, so that's why I'm just going to do it like the ancient way. Okay. Anyway, this right here is the limit as x approaching 2, and the secret of doing this is that we are trying to fix the top, right? So we are just going to multiply out the top. We are not going to multiply out the denominator. So let me write it down as how it is, which is just x minus 2 times square root of 2x plus 5, and then plus square root of x plus 7. Okay? And then on the top, let's see, when we have the conjugate, it's pretty easy to multiply out. It's just this square, which the square root cancel, and we just have regular parentheses with 2x plus 5 inside. And then it's minus this square, which is once again just inside, and that's x plus 7, like that. And as you can see on the top, 2x minus x, this is just x. And then 5 minus 7 is just minus 2, right? So this right here is actually the top. So I can actually cancel out the x minus 2 with x minus 2. And in the end, we can just plug in 2 into the remaining x, and then that's pretty much how we get the answer. And on the top, we have 1 over, and let's see, square root of 2 times this 2, so let me write down the 2 in red, and then plus 5, and then plus square root of this 2 in there, plus 7. And of course, a lot of these questions you can just do in your head, but I want to show you guys all the work and things like that. Anyway, in the end, you get 1 over. This is 9 inside of the square root, which is 3. This is also 9 inside of the square root, which is also another 3. And then together, you get 6. So 1 over 6 for the answer for the first one. And another thing that you have to be sure when you're doing the AP test is that you have to circle the right answer, right? So bubble the answer correctly on the Scantron. It was 14 years ago when I took my AP test, and then long time ago, but good experience. And in fact, I actually used some of these questions when I was studying for the AP test myself. Yeah, in fact, if you do the L'Hopital's rule, it's actually harder as well. Yeah, 3 plus 3 equals 6. Nah, just playing. Anyway, let's see. Okay, let's look at the second one. This is from 1985. Okay, if you are younger, if you were born after, yeah, I should say, if you were born after 1985, raise your hand. And I will have to tell you guys myself, yeah, I was born after 1985 as well. Anybody who is born before 1985? I think some people just get like kind of triggered because I said 3 plus 3. Okay, cool. So in fact, this question is just as old as I am. So okay, almost, okay. Anyway, right here, what we are going to do is, this is a conceptual question. We know we have this, the limit as x approaching to a, f of x is equal to L. The printout wasn't that clear, but I will just show these guys. And L is just a real number. And we're trying to find out which of the following must be true. And with that, let's see, when you have this expression, let's just come with a picture first. And this is a pretty standard picture to come with when you're talking about limits, okay? So suppose you have, let's say, a is right here, and you have a function like this, okay? Okay, first of all, f prime of a, in fact, it doesn't have to exist, because when you have a function right here, I may have just an open circle. If this is undefined, of course, you cannot even have the derivative. So this right here is out of our consideration. And this same picture is the same thing right here. f is not continuous at a, so this right here, it's also out of the consideration. And of course, we are saying that a is right here, and the capital L is the limit, which is right here. And as you can see, C is also not correct because, well, it's open circle, so it's not defined it, right? So I can say this is not a consideration as well. As long as you can come up with an example that can rule this out, then that's not correct. Right? Shh. Okay. I don't know why you say shh, but oh, I see. But it's okay. If you're gonna try these questions on your own first, you can go ahead and do so. Anyway, lastly, f of a has to be equal to L. Well, it doesn't have to be because maybe your L could be right here. It's also another possibility, right? Because as I said, as long as you can come with a picture that can make this false, then this is not correct. And lastly, the answer is this, none of the above. Nothing was right here except for, well, L is right here. And as you can see, this picture satisfies this. This was just an example. I want to use this example to get rid of this 3, right? AP is for a defense placement, and usually high school students in the United States will take the test, and if they pass the test with 3 or higher, they can get college credit. Hi, Dan. I'm actually not sure who you are. If you want to tell me your name, no. But let's see. Oh, cool. And Michael, I am trying to do this like I will try to do this more regularly, and then once again you can download the files in the description, and also I will have my website there, and you guys can go check it out. But I will organize that later. Yeah, this right here, this picture is okay. This right here, oh, I see. Well, I mean, this right here, f of a is equal to L. It doesn't have to be, right? It doesn't have to be. Sorry, I should not label the L here. You're right. You're right. Because if you go approach to A from the left, it's L, and then from the right, it's also L. So yes, L is the limit, so this has to be a picture. But the value, it doesn't have to be L. And maybe this is just like, say, 2L or something. Yeah, sorry. It's kind of, I'm using my phone, so I'm like looking at your guys' chart, and in the meantime, looking at my pictures, all that stuff. But anyway, now let's look at this one, and this is for the BC level, okay? So it's like Cal 2, that kind of thing. If you pass the BC test, you can actually get Cal 2 credit for many of the universities. Anyway, the limit as h approaching to 0, this expression, which is the integral on the top over just h, is what? Any suggestions? Go on the top. Any suggestions? Let's see. 3. Okay. Work. It's not just the answer. I know the answer as well, and in fact, I have the answer key to this as well. Derive the derivative. Sure, we can differentiate that. It's the derivative formula. Okay, that's also correct. Yeah, and I will just differentiate this because once you're in BC, you can legitimately use L'Hopital's rule. Okay, so if you want to just like get the question right, because if you're taking the test yourself, right, what you can do is if you plug in 0 here, you have 1 to 1 pretty much. So on the top, it's just going to be 0. On the bottom, it's also 0. So arguably, you can also use L'Hopital's rule. So I will. So this is by L'Hopital's rule. And this is technically a 0 over 0 situation. And I will just and if I differentiate, what should I differentiate? Which is my variable? Should I differentiate this with respect to x or h? I will just use the fundamental theorem of calculus. Yes. But my question to you guys is differentiating this with respect to x or h? Yes, h. Okay, thank you. So ddh, ddh on the top. And by the way, still write down the limit as h goes to 0. On the top, h is the variable, and when you differentiate an integral, what you can do is just simply plugging this into here. So you're talking about square root of 1 plus h, and then to the 5th power, and then plus 8 after that. And luckily, the derivative of 1 plus h is just 1, so I don't have to do anything else, right? And on the bottom, differentiating h with respect to h is just 1. And now when you have this, you can just simply plug in 0 into the h, and then you can just do the rest of the work. Square root of 1 plus 0, and then to the 5th power, and then plus 8. And this is 1 plus 8, which is 9 in the square root, which is going to be a 3 at the end, like this. And the answer to that is C. Okay? Okay, so far so good, yeah? And for the people who are in high school also, you guys can recommend, you guys can let people know about how I do this. Yeah. How do I switch my pens? Okay, take a short break. So I hold my pen like this, right? And then I kind of just move this like this, and then I kind of just switched. Okay, slow motion, like that. And I write with this pen down below. So I write like this, and then switch, switch, switch. It's pretty different compared to marker. Marker is like this, right? I told you guys marker is like, I kind of hold the pens perpendicular for markers, but for actual pens, I do it like this, right here. Okay, anyway, 1993. Anybody who is there anybody who is born on 1993? And if you are like 25 years old. Okay, so for this one, once you are in the AB level, you cannot use L'Hopital's rule, okay? That's the usual style. I would just use the trick identity, okay? Oh, you were born 1991, oh, cool. Okay, so what I will do is I will replace this, especially on the top. I have 1 minus cosine theta already, so I will use the following. Let me write down the limit as theta approaching to 0. On the top is 1 minus cosine theta. On the bottom, we have the 2 times sine squared theta. The answer to number 3 was 3. Okay. Anyway, let me get back to this, and I'll do a quick summary at the end. This right here, you can use the identity 1 minus cosine squared theta right here. And the good thing about using this is that we can actually factor it as a difference of 2 squares. You don't have to multiply, you can actually factor it, right? Because right here, let me show you. This is the limit as theta approaching to 0. On the top is 1 minus cosine theta, and we have the 2 in the front. And this right here is like 1 square minus cosine square, which you can factor it as 1 minus cosine theta times 1 plus cosine theta. And as you can see, this and that cancel each other out. And you have just the limit as theta approaching to 0. On the top is 1 over, on the bottom you have 2. And then you have this 1 plus cosine theta. And then of course I can just plug in 0 into this theta now. So this is 1 over 2 times 1 plus cosine 0. And now I'm going to do something probably that will trigger you guys again. This is 1 over 2 in the front. Cosine theta, cosine 0 is equal to 1. We have this 1, so 1 plus 1 is 2. And 2 times 2, it's equal to 4 on the bottom. So you have 1 over 4. So C is the answer. Okay. You can also use L'Hopital's rule for this one. I will show you guys if you guys prefer. But this is perhaps the fair way to do it for the exam. Okay, this is the fair way to do it for the exam, especially when you are in the AP calculus AB. Then you have to use this actually. Okay, so if you want to use L'Hopital's rule, I will show you guys this as well. First of all, we have the limit as theta approaching to 0. This is 1 minus cosine theta to sine squared theta, right? plugging 0 into the top here, you get 1 minus cosine 0, which is 1. 1 minus 1 is 0. Plugging 0 into here, sine 0 is 0, and that will make the bottom 0. So I can use L'Hopital's rule because this right here is a 0 over 0 situation. On the top, I differentiate with respect to theta. On the bottom, I also differentiate this with respect to theta. So this is going to be the limit as theta approaching to 0. We have the negative, but the derivative of cosine theta is negative sine theta, like this. On the bottom, I will bring the 2 as a power, bring that to the front, minus 1. 2 times 2, we get a 4. And then the inside states, which is sine theta. And we multiply by the derivative of sine theta, which is positive cosine theta. And then you see that that cancel out. So this is the limit as theta approaching 0. Negative times negative is positive 1 over 4 times cosine theta. In the end, you get 1 over 4 cosine of 0, which is 1 right here. And that's, once again, 1 over 4. Okay? So this is not bad neither. But as I said, AB, right, you are supposed to just use the regular way to do it without any L'Hopital's rule. We have one more question right here. So now, this is the question. The limit as h approaching to 0, ln of e plus h minus 1 over h is which of the following? And this is the BC level back in 1997. So I will wait for people to just comment the answer for this, A, B, C, D, or E. You are with A, and then, okay, Stefan with A. This is technically not L'Hopital's rule because we are asking ourselves what does this represent. So I will try not to use L'Hopital's rule, of course. So I have a lot of answers, a lot of votes for the answer A, and some people say B. Yeah, because if you use L'Hopital's rule, you actually end up with a number for the answer. That's not what we want. This is the definition of the derivative, that's right. So, yes, the answer to this is A. Okay, this is the definition of derivative. And let me just remind you guys, f prime of A in general, okay, f prime of A in general, this is by definition, it's the limit. And because we're using h, so I will use the h version, h approaching to 0, and we have f of the input is A, and then we plus h minus f of A, and then O over h. So this is the definition of derivative. And on the AP exams, they like to ask you guys this kind of questions because this is more of the conceptual questions rather than just computations. So as you can see, they match, and you can kind of see that the function is ln, right? So notice that the function is actually in our equation f of x, it's equal to ln x. And you can look at this number, and of course the a value is equal to e. So if you want to rewrite it, if f of x is equal to ln x, then f prime of e. This right here is by definition the limit as h approaching to 0. I will plug in e, which is the a, e plus h into the f function, so it becomes ln of e plus h. And then I will minus plugging this into the function, which is just ln e all over h. And you see that ln e, this right here is exactly equal to 1. And that's exactly what we have. So what we're trying to do is f prime of e, where the function is ln x, the definition of derivative. So this is pretty much it. As I said, this is just going to be a short live stream, and I think I will do more if I get good feedbacks of doing this today. I will see how people react to this, and I will still post my usual videos, my usual format, and I just like to do live stream with you guys because I like the instant interaction with you guys. And if you guys like this, I think I can do more later on, especially like over the weekend, and I can set a set schedule for you guys. And I want to target on the AP calculus questions because I know the AP calculus test is coming up within like 2 months. I'm sorry, I'm using my phone, so and I don't really have good Wi-Fi at home, so yeah, do more. I don't say it's bad. Okay, cool. And I will just set up like a live stream. And if you guys have any suggestions, like how I can figure out what's the best time for me to do live stream for everybody, you guys can leave a comment down below. And I'm actually going to end the live stream right now. And once I end the live stream, right, you guys can go back to the video. You guys can like comment there, and then so that we can all see it. Yeah. But I like to see the chart right here as well. Yeah. And yes, this right here is about 50 years old. Okay, so hopefully you guys all like this. And as always, that's it. And I'll see you guys soon. Okay, bye. Yeah, I'm serious. Yeah, bye. Oh yeah, I forgot. I should flip the camera and say to you guys. Bye. Okay, see you guys next time.